Good day, everyone. I am Jeskin J. Acevedo, the virtual version. Today, I am here to report on advanced production, operation management, specifically on the topic of scheduling. Scheduling is the process of organizing, allocating, and optimizing resources such as time, equipment, and personnel to complete tasks or deliver services effectively. In both manufacturing and service industries, scheduling ensures that operations run smoothly, deadlines are met, and customer satisfaction is maintained. The following learning objectives are: use and interpret Gantt charts, use the assignment method for loading, give examples of commonly used priority rules, discuss the theory of constraints and that approach to scheduling. Summarize some of the unique problems encountered in service systems, and describe some of the approaches used for scheduling service systems. Now let's proceed to the first learning objective: the use and interpret Gantt charts. A Gantt chart is a powerful visual tool used in project management to plan, schedule, and monitor tasks over time. It provides a timeline view of activities, helping project managers track progress and ensure deadlines are met. Components of a Gantt chart include tasks, represented by rows on the chart, timeline, displayed as the horizontal axis, showing periods, days, weeks, or months, bars, indicating the duration and start-end times of tasks, dependencies, where lines or arrows show relationships between tasks, such as which tasks must be completed before others can start. Applications of Gantt charts help identify critical tasks and milestones, detect project delays by comparing planned versus actual progress, and are useful for resource allocation by visualizing overlapping tasks. For example, in a construction project, a Gantt chart may show the foundation, framing, plumbing, and finishing phases, each with their start and end dates and dependencies. Usage includes scheduling project activities, tracking progress against the plan, identifying task dependencies and deadlines, and ensuring resource allocation aligns with project timelines. Interpretation involves horizontal bars representing tasks, with their length indicating the duration. Vertical lines show the current date. Colors or shading highlight progress, delays, or milestones. An example could be a hotel renovation project using a Gantt chart to outline tasks like room redesign, furniture delivery, and staff training, ensuring deadlines are met. Our second objective is the use application of the assignment method in loading. First, define the jobs and resources by identifying the tasks that need to be assigned, such as room cleaning, event preparation, or food service, and listing the available resources like staff members, machines, or departments. Next, create the cost matrix by developing a matrix where rows represent jobs and columns represent resources, filling the matrix with values representing the cost, time, or difficulty of assigning a specific job to a resource. Then apply the Hungarian algorithm by subtracting the smallest value in each row and column to create zero values, drawing the minimum number of lines through rows and columns that cover all zeros, and adjusting the matrix iteratively until an optimal assignment is found. Finally, assign jobs to resources by allocating each job to a resource based on the optimized matrix, ensuring no two jobs share the same resource. An example in hospitality could be a hotel needing to assign housekeeping staff to clean 4 rooms, with different estimated cleaning times for each staff member. The step-by-step process includes creating a matrix of cleaning times, subtracting the smallest value in each row and column, applying the algorithm to find the optimal assignments, resulting in each room being assigned to the staff member who can clean it most efficiently, minimizing overall cleaning time. This method is particularly valuable for hospitality students as it demonstrates how to manage dynamic workloads efficiently, a skill essential for future leaders in the industry. The third objective is the commonly used priority rules in scheduling. Priority rules in scheduling are vital tools used to determine the sequence in which jobs, tasks, or services are executed. In the context of hospitality and other service industries, these rules are applied to allocate limited resources, minimize delays, and meet customer expectations. The first rule is first come, first served, FCFS, which prioritizes tasks based on their arrival order, ensuring fairness but ignoring job urgency or complexity. Its advantages include being simple to implement and perceived as fair by customers, while disadvantages include inefficiency for tasks with varied processing times, potentially causing bottlenecks. An example in hospitality is at a hotel front desk, where guests are checked in based on their arrival sequence, regardless of the room type or special requests. The second rule is shortest processing time, SPT, where jobs with the least amount of processing time are completed first, minimizing the average time spent in the system. Its advantages include reducing overall waiting time and increasing throughput, while disadvantages may include excessively delaying long-duration jobs. An example is in a hotel kitchen, where appetizers and quick-to-prepare dishes are prioritized to maintain the flow of service. The third rule is earliest due date, EDD, which prioritizes jobs with the closest deadlines, ensuring time-sensitive tasks are completed first. Its advantages include reducing late deliveries and enhancing customer satisfaction, while disadvantages may neglect tasks with longer deadlines but higher importance. An example is event staff prioritizing setup for a wedding happening at noon over a corporate seminar scheduled for the evening. The fourth rule is critical ratio, CR, where a ratio is calculated for each job based on the time remaining until the due date and the processing time, with jobs having the smallest CR prioritized. Its advantages include balancing urgency and processing time, preventing overdue tasks, while disadvantages include requiring calculation, which may be time-consuming in real-time scenarios. The formula is CR, time remaining, processing time. An example is housekeeping prioritizing rooms with minimal preparation time left before guests check in over rooms with longer availability. The fifth rule is longest processing time, LPT, where jobs requiring the most time are handled first, often to balance workloads or utilize resource capacity effectively. Its advantages include reducing idle time for resources, while disadvantages can increase waiting time for shorter tasks. An example is banquet staff prioritizing decorating a large hall for a wedding over setting up a small conference room. The sixth rule is slack time remaining, STR, where tasks with the least slack time are given priority. Its advantages focus on completing critical tasks with limited margins for delay, while disadvantages may deprioritize tasks with more slack, even if they are strategically important. The formula is slack time, due date, processing time, plus current time. An example is cleaning a hotel room for a guest checking in early prioritized over one reserved for a later check-in. The seventh rule is weighted shortest processing time, WSPT, which prioritizes jobs based on their weighted importance and processing time, completing high-value tasks first. Its advantages align resource allocation with business priorities, while disadvantages can be complex to implement without clear weight criteria. An example is VIP guest requests, like personalized room setups, prioritized over regular requests. The eighth rule is round robin, RR, where each task is allocated a fixed time slice in a rotating sequence, ensuring fair access to resources. Its advantages include fairness and preventing job starvation, while disadvantages can be inefficient for jobs with vastly different processing times. An example is a concierge alternating between assisting in-person guests and answering phone inquiries to balance service. The ninth rule is last come, first served, LCFS, where the most recently arrived tasks are handled first, often used in specific scenarios requiring rapid turnaround. Its advantages ensure responsiveness to urgent new tasks, while disadvantages may delay older tasks indefinitely. An example is valet staff retrieving cars for the most recent customers, first during a busy evening event. The 10th rule is priority by customer class, where tasks are prioritized based on customer segmentation or service agreements. Its advantages enhance satisfaction for high-value customers, while disadvantages may create dissatisfaction among other customer groups. An example is in airlines, where first-class passengers are prioritized for check-in and boarding over economy-class passengers. Understanding these rules equips hospitality students with the ability to optimize resource allocation during high-demand periods, enhance guest satisfaction through timely and efficient service delivery, and balance competing demands, especially in dynamic environments like hotels, restaurants, and event management. Mastering priority rules is a vital competency for future hospitality managers, enabling them to make data-driven decisions and deliver superior guest experiences. The fourth objective is about the theory of constraints, TOC, and its approach to scheduling. The theory of constraints, TOC, developed by Dr. Eliyahu M. Goldratt, is a management philosophy that focuses on identifying and managing the bottleneck, or constraint, that limits the performance of a system. In scheduling, TOC emphasizes optimizing the flow of work through the system by addressing its constraints to achieve the best outcomes. Key concepts in the theory of constraints include constraint, which is any resource, task, or process that limits the throughput of the system, acting as a bottleneck. Throughput, the rate at which the system generates money or value by producing goods or services. And 5 focusing steps, which TOC uses as a continuous improvement cycle with 5 steps. Identify the constraint, exploit the constraint, subordinate everything else, elevate the constraint, and repeat the process. TOC approach to scheduling ensures that the focus is on the constraint to maximize throughput. Steps in applying TOC to scheduling include identifying the bottleneck resource, determining which resource or process is the constraint in the workflow, exploiting the bottleneck by ensuring it operates at full capacity, scheduling around the bottleneck using techniques like drum buffer rope, DBR, to manage workflows, prioritizing tasks by scheduling high priority or high value tasks through the bottleneck first, and elevating the bottleneck by investing in additional resources or redesigning processes to increase the capacity of the constraint. Benefits of TOC scheduling in hospitality include improved resource utilization, enhanced throughput, reduced bottlenecks, and better customer satisfaction. Real-world applications in hospitality include hotel room allocation, where a hotel with limited suite rooms identifies these as constraints and prioritizes high-revenue guests. Restaurant seating, where a busy restaurant schedules table turnover based on the time constraints of specific resources. And event management, where an event planner schedules equipment and staff for a large wedding and aligns smaller events around this major booking to avoid conflicts. The TOC approach to scheduling is an effective strategy in hospitality as it focuses on maximizing the efficient use of resources, streamlining workflows, and enhancing overall guest satisfaction. The last objective discusses the unique problems in service systems and scheduling approaches. Service systems face distinct challenges compared to manufacturing systems, primarily due to the intangible, perishable, and often customer-driven nature of services. Unique problems in service systems include demand variability, where customer demand fluctuates due to time of day, season, or external factors. Customer involvement, where customers are often part of the service delivery process. Intangibility and perishability, where services cannot be stored for later use. Employee variability, where the quality and speed of service often depend on employee performance. Service time uncertainty, where the time required to complete a service often varies based on customer needs. And simultaneous production and consumption, where services are consumed as they are produced. Approaches used for scheduling service systems include demand forecasting and capacity planning, flexible workforce scheduling, appointment scheduling, queuing models, priority rules for scheduling, real-time scheduling, service blueprinting, load balancing, revenue management, and time buffering and overbooking. Service systems are inherently complex due to their customer-centric nature and demand variability. Effective scheduling approaches such as demand forecasting, priority rules, and real-time adjustments help optimize resource allocation, reduce bottlenecks, and enhance customer satisfaction. These methods ensure service delivery remains efficient, even in dynamic and unpredictable environments. The topics discussed provide valuable insights into the complexities and strategies involved in managing operations and scheduling in service systems. By understanding the unique challenges and applying appropriate solutions such as forecasting, real-time scheduling, and customer-focused approaches, businesses can enhance efficiency and customer satisfaction. As future hospitality professionals, it is essential to integrate these principles into our practices to ensure we deliver exceptional service while optimizing resources. Let us take these lessons forward, recognizing their importance in shaping a successful and sustainable career in the hospitality industry. Thank you for your attention.